It is another exciting day in Algebra 2. Today we are looking at synthetic division, which is our simplified process for dividing polynomials, which we learned last time. So something to note here, the reason that we still had to learn the long way is because you can only use synthetic division when your divisor, the thing after your division symbol, has an exponent of 1 and a coefficient of 1. If you have a coefficient other than 1 or an x squared, you cannot use synthetic division. It will not work. You have to use long division. So what are the steps? Well, if this is my dividend, my polynomial in standard form, and this is my divisor, what we're going to do is make an upside down house. So kind of like your long division house, but upside down. And what we're going to put inside are all of my coefficients in descending order. So those numbers in front. And then what's going to go outside is the opposite sign of whatever the constant in my divisor is. So if it was positive, this outside would become negative, vice versa. Then the pattern goes, you're going to bring down your first number. It's not going to change. You're going to multiply it by what's on the outside, add that to your second number, multiply, add, repeat, until you get to the very end. Your last number is going to be your remainder, and then these other numbers are going to be the coefficients of your answer in decreasing order. So let's jump into an example because I feel like this is really best learned by seeing and doing. So on this first one, I'm going to start with my upside down house. My coefficients are 5, -6, 4, -1. My divisor is x minus 3, so the opposite sign of that will be positive 3. That's what's going to go outside my house. And now I'm going to start my pattern. I'm going to bring down the 5. 5 times 3 is 15. -6 plus 15 is 9. 9 times 3 is 27. 4 plus 27 is 31. 31 times 3 is 93. -1 plus 93 is 92. So again, that last number is your remainder, and then these are the coefficients for your result. Now your result is going to start with one exponent less than your initial dividend. So if I started with x cubed, that means my answer is going to start with x squared. So my answer will be 5x squared plus 9x plus 31. Then I have my remainder, and that is going to be 92 divided by our divisor, which was x minus 3. So there is our final result. Let's do that again on example 2, upside down house. My insides are going to be 1, 4, 1, -6. And then opposite of x plus 1 will be -1 on the outside. I'm going to repeat that process, bring down the 1. 1 times -1 is -1. 4 minus 1 is 3. 3 times -1 is -3. 1 minus 3 is -2. -2 times -1 is +2. -6 plus 2 is -4. That's my remainder. These are now my coefficients. Again, I'm going to start with x squared because that's 1 less than my initial power. So x squared plus 3x minus 2. Then my remainder, 4 over x plus 1. All right, let's move on to a few more examples. On 3, setting up my house again. 1, -2, -5, 6 are going to go inside. The opposite of that is -2. That's what's going to go outside. Bring down the 1. 1 times -2 is -2. -2 minus 2 is -4. -4 minus -2 is 8. -5 plus 8 is +3. 3 times -2 is -6. 6 minus 6 is 0. So because that's 0, that means I have no remainder here. So I'm just going to look at my coefficients. Again, I started with x to the third, so my answer will be x squared minus 4x plus 3. Moving on to 4. Inside my house, I need to go in decreasing order. I have x to the fourth with a 1, but I go from x to the fourth to x squared. I don't have a term that has x cubed. So I'm going to need to put a placeholder there of 0 in order to make sure that my division works properly. Then I've got -5, 4, 12, and then the opposite of +2 is going to be -2. So I'll bring down the 1. 1 times -2 is -2. 0 minus 2 is -2. -2 times -2 is 4. -5 plus 4 is -1. -1 times -2 is +2. 4 plus 2 is 6. 6 times -2 is -12. And again, I end up with a remainder of 0. And then I started with a power of 4, so my result is going to start with a power of 3x cubed minus 2x squared minus x plus 6. All right, on to 5. Use synthetic division to determine whether this is a factor of our polynomial. Now, to determine if something is a factor, that is when you divide and you end up with a remainder of 0. If you end up with a remainder other than 0, it is not a factor. So that's what we're going to do. We're going to do synthetic division and look for our remainder. So we have no missing terms here, so I can put all my coefficients in straight away. This is x minus 1, so plus 1 is what will go on the outside. Bring down the 3. 3 times 1 is 3. 10 times plus 3 is 13. 13 times 1 is 13. Negative 1 plus 13 is 12. 12 times 1 is 12. Negative 12 plus 12 is 0. My remainder is 0, so yes, x minus 1 is a factor. All right, our last one, we're going to use synthetic division to completely factor this polynomial. So setting up my house, I'm not missing any terms, so I don't have to worry about a placeholder. The opposite of positive 1 is negative 1. That's what will go on the outside. So I've got 1 times negative 1 is negative 1. 2 minus 1 is 1. 1 times negative 1 is negative 1. Negative 5 minus 1 is negative 6. Negative 6 times negative 1 is 6. Negative 6 plus 6 is 0. So I have no remainder, which means when I factored out x plus 1, what I had left over was x squared plus x minus 6. This is now a trinomial that I can use my x method to finish factoring. So a times c here will be negative 6. b is 1. Numbers that multiply to negative 6 and add to 1 are 3 and negative 2. Because a is 1, I don't have to worry about dividing these. So I have x plus 1, and then that trinomial factors into x plus 3 times x minus 2. So now we have completely factored that original polynomial. All right, now that's fine and dandy at all, but how did we figure out that x plus 1 was a factor? Well, we used something called the rational root theorem. So your rational root theorem takes all of the possible factors of your leading coefficient and all the possible factors of your final constant and divides them. So what we end up with are a list of possible factors, and then we would have to do long division or synthetic division to check. We want to see if it's a remainder of 0, and then we can write it in factored form. So let's jump into an example on that here as well. First, we want to find all the possible rational roots. So here, my leading coefficient is 2. So p is going to be all of those possible factors. Well, 2 is prime, so it's just 1 and 2, but it could be positive negative 1 or positive and negative 2. Moving on to my last constant, I have negative 10, so q could be all of the possible factors of 10. So we have 1 and 10, obviously, also positive or negative, and I also have 2 or 5. So those are my possible values for p, those are my possible values for q. To find p over q, I need to divide each of those. So I'm going to start with just p. P could be 1. So I could have 1 over 1, which is just 1. I could have 1 over 10, which is 1/10. I could have 1 over 2, which is 1/2. And I could have 1 over 5. Then if I use 2 for p instead, I could have 2 over 1, which is just 2. I could have 2 over 10, which is 1/5, which I already have. I could have 2 over 2, which is 1, which I also already have. And then I could have 2 over 5, which is 2/5. So those are all of my possible roots. We would then go on to test them, which is what we will do on the next 2 examples. So first we're going to find all of our possible roots. Here p is 2. So again, those 2 possible factors are positive negative 1, positive negative 2. My last constant is negative 3, so q could be positive or negative 1 or positive or negative 3, which means we have fewer options for p over q. If p was 1, then I could have 1 over 1, which is just 1, or I could have 1 over 3. Then if p is 2, I could have 2 over 1, which is 2, or I could have 2 over 3, which is 2/3. So those are all of my possible roots, but I'm just going to focus on the whole numbers. So I have plus or minus 1 or plus or minus 2. This is now where we will use synthetic division to test the factors. So let's start with just going in order, plus 1. If I wanted to test x plus 1, that means what would go outside is negative 1, and inside is your 2, I don't have an x squared term here, so I need a 0, 1, negative 3, and we're going to do synthetic division. And all I am looking for is my remainder 0? And it is not, so that's not a factor. Now let's try x minus 1. If I did positive 1 on the outside, the insides are still the same. And look at that. I got a remainder of 0, so that means x minus 1 is the factor. If this had not worked, we would have gone on to test positive 2 and negative 2. But what that means is when I factor out x minus 1, what I'm left with is 2x cubed plus x minus 3. Now, this is a trinomial here, and that should have been x squared. Apologies. If I were to do my x method here, 2 times negative 3 is negative 6. And again, apologies, that should have been a 2 in there. I don't know where my head is at. My b value would be 2. There are no factors that multiply to negative 6. And that would also be a positive 3. Geez. That multiply to positive 6 and add to 2. There are none. So this cannot be factored any further. This is our final answer. Okay, moving on to our last problem. Our leading coefficient is 1, so p can only be plus or minus 1. And our last constant is 8, so we could have 1 and 8. We could also have 2 and 4. So our possible values for p over q are going to be 1 over 1, which is just 1. 1 over 8, which is going to be a fraction. Again, I only want the whole numbers. 1 over 2, also going to be a fraction. 1 over 4, also going to be a fraction. So these are the only ones I'm worried about testing. If we want to test x plus 1 first, in my house, I don't have any missing terms this time. Negative 1 will go on the outside. So doing my synthetic division really quickly. That does not have a remainder of 0, so let's try x minus 1 instead. And I did get a remainder of 0, so this one does work. And if I were to factor out x minus 1, what I would have left is x squared plus 2x minus 8. Looking at this trinomial, if I do my x method, 1 times negative 8 is negative 8. Our b value is 2. Numbers that multiply to negative 8 and add to 2, 6. Sorry, not 6. Positive 4 and negative 2. So this can factor out further. That x minus 1 stays in the front. And I can factor the trinomial into x plus 4 times x minus 2. And that is my final factored answer. So, synthetic division, rational root theorem, you've got it now.